All right, 8.4, testing the difference between proportions. So two sample z-test for the difference between proportions. In this section, you will learn how to use a z-test to test the differences between two population proportions, P1 and P2, using a sample proportion for each population. If a claim is about two population parameters, P1 and P2, then some possible pairs of null and alternative hypotheses are, and these are listed, the equal to, not equal to, lesser than equal to, and greater than, and then a greater than equal to and less than. Always assume there is no difference between the population means, P1 equals P2. These conditions are necessary to perform a z-test for the differences between two population proportions, P1 equals P2, when the samples are independent. The samples are randomly selected, the samples are independent, and the samples are large enough to use normal distribution. That is, N1 times P hat is greater than or equal to 5, and N1 times Q, not P hat, excuse me, P bar, N1 Q bar into P bar and into N1, excuse me, Q bar. Should be a 1 or greater than or equal to 5. So instead of N times Q, we have PQ, P and Q bar. Let's talk about what that is. That is the weighted estimate of P1 and P2. So P bar is the weighted estimate of P1 and P2 and is calculated by adding your X values divided by the addition of your sample sizes. The weighted estimate of Q hat is Q hat is equal to 1 minus P hat. So it's still the complement. When these conditions are met, the sample distribution for P hat 1 minus P hat 2, the difference of the sample proportions is a normal distribution with the mean. And then there's our mean, P1 minus P2. And then standard error is P bar Q bar times 1 over N1 plus 1 over N2. The test statistic is P hat 1 minus P hat 2. And the standardized test statistic is, so let's look at that. P hat 1 minus P hat 2 minus P1 minus P2 with the parentheses divided by the standard error, or the square root of P and Q bar, 1 over N1 plus 1 over N2. I know it's a lot, but those who like to use the formula, you normally understand this. And then calculator. There is a test. It's called the T-prop-Z test. 2-prop-Z test, excuse me. 2-prop-Z test today, too many times. All right, and this is because we're looking at the differences between two population proportions. So you're going to enter in, that should be just one X with a bar on top of it. It's doubling. X1 and N1. If needed, X1 is equal to N1 times P hat 1. Remember, many times they'll give you P hat, but sometimes if they don't, many times they'll give you X and N. If they don't give you X and N, you're going to use N1 times P1, P hat 1 to get your X1. And we have an example of that, of course. So in the calculator, X1, N1, and then X2, N2 in your calculator. It's actually, the bar should be missing from that, but we'll get to that. And then for P1, highlight HA inequality. For pooled, yes if your variances equal, or no if your variances do not equal. Actually, I think that's for another section. Let me mark this out. Yeah, that's for another section. Forgot to mark that out, so just delete that. Yeah. All right, so steps to hypothesis testing. So we've gone over the formula. This is your standard error. And then we've gone over the calculator. So this is how you find your Z manually. This is how you're going to get your Z manually, where Z is going to be your standardized test statistic. And P will be your p-value. And the calculator. So steps to hypothesis testing. So this is the same as we've been doing for every section, but of course it varies per section. You want to verify the samples are random and independent. We don't have a mean, so we're not going to use the central limit theorem to make sure we can do our problem. We're going to verify with N1 P bar, N1 Q bar, M2 P bar into Q bar to make sure they're all greater than or equals to 5. So they have to be at least be 5 to do these problems. We're going to state the claim mathematically and verbally, identify the null and alternative hypothesis, that's HO and HA. Your level of significance, we're going to identify that. Critical value is going to be Z naught. We're going to determine our rejection regions. We're going to find that standardized test statistic, Z, and then graph it if you want to with the Z naught. Find the p-value, make a decision, and interpret the decision. So as a reminder, to find a critical value, Z naught, use table 4 on the formula sheet or inverse norm in the calculator. To determine the rejection region or tail, we use HA. We look at HA. And then to find X1 and X2, as we did up here, N1 times P1, P hat 1, or N2 times P hat 2. And you want to round to the nearest whole number. So round as usual. Don't always round up. Okay. So first problem. So study of 200 randomly selected people driving vehicles in Washington and 250 randomly selected people driving vehicles in Vermont shows that 93% of the people driving vehicles in Washington and 88% of the people driving vehicles in Vermont wear seatbelts while driving. At level significance 0.10, can you reject the claim that the proportion of people who wear seatbelts while driving is the same for Washington and Vermont? So we're trying to see if they're the same for Washington and Vermont. All right, so we have Washington, we have Vermont. So Washington is going to be our 1, Vermont's going to be our 2. Notice they give us N for 200 and N for S250 for Washington and Vermont, respectively. They also gave us P. P1 was Washington. P2 is Vermont. They didn't really give us this. To get X, X was equal to N times P hat. And this X was equal to N times P hat. That's where they got those numbers from. So just in case you don't see your X1 and X2, that's how they got those numbers. All right. So 200 times your P bar and 250 times your P bar. That's how you check your actual weighted mean to make sure you can do the problem. So remember, P bar is X1 plus X2 over N1 plus N2. So X1 plus X2 to 22 over N1 plus into, calculate that, 408, and then that's 450. That gives us a p-bar of 0.9067. Put this in the screen so you can see it. Hopefully you can see it. So this is what you multiply to make sure that your you have enough sample or success. So 5 for each. And then Q bar is going to be the opposite of this. Zero 0.0933. So if you wanted to check really quick to make sure you can do your problem, 200 times 0.9067. Okay. 200 times 0.0933. Okay. That's over 5. So now we're going to do the same thing for the 250. So 250 times 0.9033. Everything's over 5, so we're good to go. We just verify the weighted mean. We're all over 5. We're good to go. All right, so let's look at that claim. What is the claim? The claim is stating that the proportion of people who wear seatbelts is the same for Washington and Vermont. So it's the same. So where does that go? Good. HO. That means our HA is opposite. All right, level of significance is 0.10. Let me just verify that, okay? This is a two-tail because of HA. Oops, sorry, I can't see that. So if you're using p-value, you're good to go. You're going to put the information in the calculator. For those who are using the formula, let's work out our critical value first. Critical value Z naught. This is two-tail. So this means that we're going to take our level of significance and divide it by 2. If you're using table 4, you would take this level of significance divided by 2 and find that area on your table. So this is second bars. Inverse norm. Divide this by 2 because it's two-tail. So that's a negative and positive. Negative and positive. Any Z less than negative 1.645 or any z greater than 1.645 will reject HO. So that is our rejection region if you're using a formula. Z naught. Then I'm going to set up the calculation for Z, and I'll let you calculate it on your own because I'm going to get the Z out of the calculator when I run my test. So this is going to be P hat minus P hat. I think I have it wrong up here. Let me change it. 0.880. I think I had something else earlier. Okay. Then minus 0, because we always assume that they're equal. Then let me bring this back in. Standard error. It's a square root. P bar Q bar. And then 1 over N1 plus 1 over right room N2. Again, be careful when putting this in the calculator. You want to make sure that's in parentheses, and then you have to close that parentheses with the square root. Okay? So please be careful if you're doing this by hand. So I'm going to prop z-test. Sample is for the means. So to prop z-test. All right, ready? So that's stat test. Stat test to prop z-test. So X1, we'll come back up. X1 is 186. N1 is 200. X2, I'm going to show you how, remember in the original problem, they didn't give us the X2. They did give us N and P. So you can actually do 250 times P. And notice how it gives you that number. That's 250. My P1, I want to make sure it matches my HA. Let me do that again just in case I didn't see it the camera. Do that 250 times 0.888. There we go. Then my HA. Then we want to hit calculate. So 1.52. So when you put this in the calculator, you should get 1.52. So Z equals 1.52. Let me correct this. It should have been 888. Something was off. 0.888. C is equal to 1.52. P is equal to 0.1280. That's a probability. So we want 4 digits. Now we're ready to make our decision. So Z, any Z greater than 1.645 will reject. So this Z is not greater than 1.645. So we reject HO. Excuse me, fail to reject. Fail to reject HO. Fail to reject HO. It is not greater than 1.645. Then our p-value, we compare it to our level of significance. It's low, it's got to go. It's high, so it's going to fly. That means this is true. That's false. So when we get a fail to reject HO, that means that there is not enough evidence at the 10% level of significance to claim as an HO, reject the claim. So there is not enough evidence to reject the claim. Okay, so that means that they didn't reject it. That means it was true, or they were about right. All right, last problem. Get my station together, sorry. All right, a medical research team conducted a study to test the effect of a medication to treat patients with post-traumatic stress disorder, or PTSD. At the end of the study, the researchers found that 42 randomly selected subjects who took the medication, 28 no longer met the diagnostic criteria for PTSD. Of the 37 randomly selected subjects who took placebo, 12 no longer met the diagnostic criteria for PTSD. At level significance 0.01, can you support the claim that the reduction rate in the diagnostic criteria for PTSD is higher for those who took the medication than those who took the placebo? All right, so we do know it's random. We do know it's independent, the samples are. Now we have to find our weighted mean. So they gave us X in these problems. They didn't give us P hat. They gave us X. So to calculate P hat, you divide it in X, N into X, or X by N. So that's how you got those P hats. So just in case they didn't give it to you, that's how you calculate them. So the first one they gave us the P hats. The second problem they gave us the X's. All right, so that's X1 plus X2 over N1 plus N2. Again, this is for using the formula. So 28 plus 12 over 42 plus 37. That's 40 over 79. 40 over 79, 0.5063 for P bar. Q bar is going to be the opposite of that. So that's 4937. 4937. All right, so let's look at the claim. So the claim is stating the reduction rate in the diagnostic criteria for PTSD is higher for those who took the medication than for those who took the placebo. All right, so that means claim higher I'm trying to I think I used the mean last problem. It's supposed to be P. I just thought about that, y'all. I'm so sorry. So that's supposed to be P. So I was looking at the problem. So P1 greater than P2. So let me fix that right now. It's one of those days, y'all. So that's P1 I normally write my notes out because I need to go back to doing that. Those are P's. P. P. All right, so that goes into HA. Opposite of that. Okay, so our level of significance is 0.01. Our tail is pointing to the right for HA, so this is right. That means critical value, inverse norm. Now, I will say some of these calculators are different. So your calculator may be different how to calculate for inverse norm. I don't have a left, right, or two-tail calculator. So I have to manipulate my level of significance to make it right. So 1 minus 0.01. 2.33. So any z greater than, because we're looking on the right, will reject HO. Again, I do apologize. Those are P's for that previous problem, not means. All right, so for those who want to calculate Z, let me set this up for you. So P1 minus P2, and notice, put them in order. That's going to be 0. Then we do our P bar, Q bar. Again, if you are Using the formula, make sure that you are keeping your numbers straight. I don't have parentheses around the formula itself when I work it out, but when I put in the calculator, I like to, or when I have decimals, I like to make sure that you know where I'm getting the numbers from and you're not confused. Okay, so 1 over 42 plus 1 over 37, that's in parentheses. Again, be careful when you're putting that in the calculator. I'm going to use my 2-prop z-test. 2-prop z-test to get my numbers, my z and my p, my standardized test statistic, and my p-value. So I'm going to stat test. Make sure I can see this. Sorry. 2-prop z-test. 2-prop z-test. I'm going to put in my numbers. X1 and N, X2 and N, and my HA needs to match. Calculate. So Z we use 2 decimal places because that's what table 4 has. P we're going to use 4 decimal places because it is a probability. 0.0012. 0.0012. So let's make a decision. Any Z greater than 2.33 will reject. Ours is 3.04, so we're going to reject HO. Then our p-value, comparing it to our level of significance. That's a penny. That's way less than a penny, so we're going to reject HO. P was low. HO's got to go. So reject HO means there is enough evidence. At the 1% level of significance, 2, our claim was an HA, so that's a support. The claim, I'm going to get my P's right this time, y'all. P1 is greater than P2. All right, until next time.